Hello everyone, this is Mayuk Mazumdar and I'm back with another exciting session. So let's proceed. In this session, I'll be giving you a brief tour of this standard library. The first one will be the operating system interface. The OS module provides dozens of functions for interacting with the operating system. So to import that, we have to use the import OS statement. Now let me get the current working directory in which I am working. So when I do run so, it shows me home menu, PyCharm projects, preaching Python, session 7. So this is my working directory, current working directory. So we can also use OS package to change the working directory to some other path, or we can also use OS to execute any Linux command. Maybe suppose mkdir, suppose I'm going to make a new directory. So mkdir space directory name. So if I execute this, then a new directory with the name folder path, folder name will be generated. Or using this, the current working directory will be changed to some other directory. But I'm not going to do any of this, but this is the syntax to do so. So now let me print the list of all the module functions that Python gives us. So when I do so, when I print dir of OS, it gives me list of all the module functions of Python. It's a huge list, so need not think about it much. Now let's introduce to another package, that is shuttle. So using this shuttle, what we can do, we can copy a file from copy the contents of a file from file A to file B. Suppose at many times you may require that we have to copy the contents of a file from one file to another, so we can easily do so. Or we can move a file from one source path to a destination path, so we can easily do so using this shuttle package. Now be sure to use the import OS style instead of from OS import star. This will keep os.open from shadowing the built-in open function, which operates much differently. Now for daily file and directory management tasks, the shuttle module provides a higher level interface that is easier to use. The next topic is file wildcards. Now the glob module provides a function for making list from the directory of wildcards. Suppose at times you don't know that how many files are there in a specific folder, or maybe you have to iterate over each contents of all the files that are present in a specific folder and do some operations. So for that you need to initially know the name of that to open the file. So to do so, you can easily do so by using this glob package. So from this, what am I doing? I am printing that all the file names star.py. This star.py shows that all the file names that are present with the extension .py now in my current working directory. So see, you get to see that there are four elements in this folder, but out of them 3 of them are .py of type .py. So that's why you get to see that when I print all the using glob.glob, when I print all the files with having a .py extension, it gives me a list containing all the file names. The next thing is command line argument. Now this is one of the very crucial component or conception in Python. Now why so? The common utility scripts often need to process command line arguments. These arguments are stored in the sys module's argv attribute as a list. For instance, the following output results from running Python with the command line. Now let me show you that I'm importing the package sys, and I'm printing all the system.argument that it accepts. So to do so, what am I doing? I'll be printing my session 7.py with a list of example. Maybe that can be human, or maybe animals, maybe mammals. These are the three arguments that I am passing to the my program. So when I do so, when I print the sys.argv, it prints me all the system arguments. So the system argument at position 0th is the file name. The system argument at position 1 is the first argument that I've passed. At position 2 is the second argument that I've passed. At position 3 is the third argument that I have passed. So as you get to see that we can pass various arguments and we can easily catch them using this sys.argv. So at times it may be necessary that for each run we have to pass specific values of the hyperparameters to tune our ML model or to tune our model or to operate in our program in any way it may be like. So for that we may need to pass these values dynamically, and it can be easily done using the command line argument. Now the arcparser module provides a more sophisticated mechanism to process command line arguments. The following script extracts one or more file names and an optional number of lines to be displayed. Okay, so let me show you how so. So I have imported this package argument parser. Now I have defining an object of argument parser class, and with a description, this is a sample I can give or may not, that's okay. Now I am adding an argument file name, and then I am adding an argument -l or minus lines, whose type is int and the default has been allocated to 10. Now I am creating this object of this parse args function. Now when I print this object, let's see what happens. Now to do so, I'll be passing some command line argument as well. But in this case, I have to pass a file name as per my use case. So my obsession with the Belacha, so I'll be passing that file as an argument, and let me run and I'll explain to you. Now what it shows is that it creates a namespace to namespace, which is an object having the file name and the line 10. So the default value is a line 10. So my aim was to create an object that will show me the first 10 lines of the file name that I passed. Now if I modify this call to -l20 and if I run, so see my object gets modified to lines 20. Initially I have not specified, so that's why it took the default value. So this is the activity of the argument parser or the command line arguments that we can pass. Now the next topic, that is error output redirection and program termination. The sys module also has attributes for stdin, stdout and stderr. The latter is used for emitting warnings and error message to make them visible even when stdout has been redirected. So what am I? I'm doing at times in our program we may feel like that we have to at times we may feel like that we have to print some warning or print some errors in the program, but still we would not like to prevent the execution of the program. So in such situations, what we can do is we can use the package sys. So using sys.stder.write, I'll be logging a warning. Suppose maybe I'll be printing a warning that is log file not found, so starting a new one. So if I run this program, see I can't manually print a warning saying that the log file is not found, and so we are starting a new one. You can give anything over here. Suppose warning variable declaration is incorrect. So when I do so, see I can print or variable initialization is incorrect. whatever we would like to log as our output to the terminal screen. Now, the next topic is string pattern matching. Before that, I would like to introduce you to regex or regular expression. Regex or regular expression is a sequence of characters that forms a specific pattern. Regex can be used to check if a string contains the specified search pattern or not. The Re module provides regular expression tools for advanced string processing. For complex matching and manipulation, regular expression offer sub-end optimized solutions. The Re module offers a set of functions that allow us to search a string for a match. So the function and the description are: the first function is the find all function. What it does, it returns a list containing all matches. The search function returns a match object if there is a match anywhere in the string. The split function returns a list where the string has been split at each match. And the sub function, it replaces one or many matches with a string. The first one is the find all function. So what it does, it returns a list containing all the matches. If not, then it returns an empty list. So for that, I'll be importing the package Re. Now, let me show you what I'm doing. I have a text statement as which foot or hand fell fastest, and I'm going to find all the expression which matches a blank space followed by F. This is my search statement, and then it can contain anything between A to Z, and so that's why a star is used as well. So when I do so, it will return me a list containing all the list that matches my search query. The next is, I am also defining another text statement as the rain in Spain, and I am trying to find out the presence of Portugal in it or not. So when I run this code snippet, I will get to see that, sorry, I have not locked this. I'll get to see that the position of all the terms that the first list contains all the terms which have the pattern matching with this regular expression, and in the second, when I was trying to find out presence of Portugal in this using the find all function, so I got a blank list stating that this term is not there. The next function is the search function. So the search function searches the string for a match and then returns a match object if there is a match. If there is more than one match, only the first occurrence of the match will be returned. So for that, similarly, I am defining a code snippet where the text is the rain in Spain, and I am searching for R, for an element for the character R, and I am printing the first appearance of R is located in this position. Also, I'm making a search with the term Portugal, and I'm printing whether the location at which the term Portugal is present. When I do so, when I run, see, I get to see that the first appearance of R, the character R, is located in position 4. 0, 1, 2, 3, 4. The indexing, as I said in my earlier classes, of string. Now, and when I search over Portugal, see, I get to see that the position is none, as it is not present. So this is how we can use the re.search. Now the next thing is the split function. The split function returns a list where the lists have been split at each match. So this also, at many times while string handling and coding, we get to find that it is required to split a string as per our requirement. So this comes quite handy. Now what am I doing? I have defined a string, and I'm going to split that with space. Wherever there is a space, I will split the syntax value. So it returns me the list containing all the elements when I have splitted the entire string by at white space. Now the final function is the sub. this sub function replaces the matches with the text of your choice. So what it does is, I have a text where it says cat in the hat. Now I'm using the sub function to replace any repetitive occurrence of any word. So for that, when I do so, if I run this, I get to see that cat in the hat. So any repetitive occurrence will be eliminated from here, from the text. So also you can use the function as per your use case. I was just demoing a sample example. The next thing that we'll be talking about is the math module. The math module gives access to the underlying C library functions for floating point math. So let me show you how I'm using the math module to print. So I have imported the math module. Now I am calling the cos function to return me the math.pi/4, cos of math.pi/4. I'm using the log function to return me log of 1024 to base 2. So when I do so, I get to see the corresponding outputs. Now the next thing is the random function. The random module provides a tool for making random selections. So I have defined a list containing 3 elements: apple, pear, and banana. Now I'm going to make a random choice among them using this random module. Also, the next thing is, I'm going to make a sample of 10 elements from the range of elements starting from 0 to 100 using this range function, and the random module will do the sampling. So when I run, see, a random choice have been made and it randomly selected pear, and a random sample of the elements in the range of 100 of 10 elements have been formed containing this element. Now if I rerun this script again, see, the random choice now made a choice of banana and also the elements change. Now if I rerun again, see, it's pear. Now if I rerun, it's pear again and the number changes. If I rerun, it's pear again. So randomly it selects. Now say apple. So randomly it selects a set of numbers. So for random selections, we can use this random module, and it's quite handy at some places. Now the statistics module calculates basic statistical properties like the mean, the median, variance, etc. of numeric data. So what have I done? I have imported the module statistics using import statistics. I have defined a list containing some elements named as data. Now I am printing the mean, median, and variance of this data. So when I do so, when I run, I will get to see the mean, the median, and the variance of the data printed. So we can use this static module to perform such operations. The next article is about internet access. There are a number of modules for accessing the internet and processing internet protocols. Two of the simplest are urllib.request for retrieving data from URLs and smtplib for sending email. So I'll be showing you how I have leveraged urllib.request to check internet connectivity. Now I've imported the package and now I've defined the function internet on. So what am I doing? I'm trying to open google.com and it will return true if it can open, otherwise it will give me an error. So I'm checking if return on, so I'm calling the function return on, and if it returns true, then I'll be printing internet connection is stable, and I don't need to check the else statement because if it's an error, so already over here an exception will be printed. And let me run this code snippet. So when I run, I get to see that my internet connection is stable, and so it shows by the script. Now I am trying to read the content of the response when I call an HTTP, when I make a HTTP request. So what's the response there? I would like to print that. So same, I'm importing the package and then I'm using URL open method, I'm opening google.com, and in whatever the line is there in the response, I'll be printing each line. So when I do so, I get to see that the HTML version of the google.com or google.com page will be displayed over here. So it can be any URL as per your choice. I just give a demo representation. So the next one will be the date and times. The datetime module supplies classes for manipulating dates and times in both simple and complex ways. While date and time arithmetic is supported, the focus of the implementation is on efficient member extraction for output formatting and manipulation. The module also supports objects that are time zone aware. So I'll be importing from datetime the import date function. Now I'll be making an object named as now that will be from the date time, means the date of today. So when I'll be printing the variable now, you will get to see that the date of the today's date will be printed. And I can also print it by using str time format, that is 06 June 2020 is a Saturday on 6th day of June, and any manner in any format that we can see. So it's just basically alignment of the representation. Also, datetime format supports the calendar arithmetics. So let me define my birthday. So I've defined my birthday as a date object for 26th October 1996, and now I'll be substituting from today's date my birthday, and I'll be printing how many days are there in between, means how many days I have lived. So when I run that, it shows me 8624 days. That's quite a long time. Yeah, but I'm not old yet. So this was about the datetime formats. The next is the performance measurement. Some Python users develop a deep interest in knowing the relative performance of different approaches to the same problem. Python provides a measurement tool that answers those questions immediately. Now in this example, we are using the timeit module to quickly demonstrate the performance measure of two tasks. Let me show you that I have imported the module. Now I'm printing one swapping task or swap function where I am defining a temporary variable, allocating the value to a value of a to temporary variable. Then I am allocating value of b to variable a. Then I am allocating value of temporary variable to variable b, and defining a equal to 1, b equal to 2. Now the same thing I am doing by just simply using the definition a comma b equal to b comma a, and a equal to 1, b equal to 2. So I'll be measuring the time taken by each execution. So when I do so, I'll get to see that the second operation took less time than the first operation. So this is how we can measure the performance of any code snippet. In larger program sets, it's often required to do so. The next is quality control. Now, one approach for developing high quality software is to write tests and each function as it is developed, and to run those tests frequently during the development process. So the unit test module is not as effortless as the doc test module, but it allows a more comprehensive set of tests to be maintained in a separate file. So for this, I have defined a function named as average. What it does, it computes the sum of the values that it receives and divides it by the length of the values, means the total length of the elements or the total count of the elements, and it returns the average. So I've imported the unit test module. I've defined a test function class, and there I've defined a function named as test average. So what am I doing? This self.assert equal, it lets me define that what should be the optimal. When I call the function average with the values 20, 30 and 70, it should return me 40 as the output, the ideal use case. or if I find the average of 1, 5 and 7, so it should give me the average as 4.3. 1, 5, 7 as a list and 1 also the variable, so it should give me 4.3. so I've defined these two appropriate use cases. So with the assert equal, I'm defining the use cases. Now what am I doing, that I am alert raising that 0 by division error if it happens at times when I return a blank, suppose empty statement. So it should send me a 0 by division error, and if not, so what am I doing, I am calling the function average with the values 20, 30 and 70. So ideally it should return 40, and I have defined it in assert equal situation. So when I call this unit test.main method, so when I run, it will show me an output that one test ran one test in 0.000 second and it passed, it's okay. So when I call the function average with 20, 30 and 70, it returned me an output of 40, which the system knows. That's why it says that the test case ran successfully. The next component will be the various outputting format or the output formats. So for that, I'll be explaining to you the two modules. The first module is the Preprint module. The Preprint module offers more sophisticated control over printing both built-in and user-defined objects in a way that is readable by the interpreter. When the result is longer than one line, the pretty printer adds line breaks and indentation to more clearly reveal the data structure. So now I have this list of lists over here and I am pre-printing it. So let me first print with the width 100. So when I do so, the printing is okay. Now to align it or to width 50, so let me specify the print, and now you get to see that the objects are being printed as per the specified width. Suppose 30 is my allowed width, so in that scenario when I print, so I'll get to see that it's printing in this format. So using the preprint, we can format our output as and whenever required. The text wrap module formats paragraphs of text to fit a given screen width. The next module will be the text wrap. So I have defined a paragraph about the text wrap method, and I'm printing. I'm using this dot fill method to width 75. So when I do so, I'll get to see that the width is set to 75. If I reduce the width to 50, let's see how it shows. So see, so you can assign or align the width as per your use case, and you can use the text wrap method to format paragraphs of text to fit a given screen width. Then we come to templating. So the string module includes a versatile template class with a simplified syntax suitable for editing by end users. This allows users to customize their application without having to alter the application. The format uses placeholder names formed by $ with valid Python identifiers. Surrounding the placeholders with braces allow it to be followed by more alphanumeric characters with no intervening space. Writing $$ creates a single script $. So I've imported the module. I've defined a template where it will accept the village name. So I will print the statement. So just let me run it. You will easily have a clear picture. Okay, sorry. So comment it out and then run it. So when I do so, see the village name have been substituted by the parameter that I've passed for the keyword village, and so so it said Nottingham folks sent $10 to the ditch fund. What's the cost? That is the ditch fund. So using this, you can output your format. You can format your outputs in multiple manner. The next one is logging. The logging method module offers a full featured and flexible logging system. At its simplest, log message are sent to a file or to system.stder. Now what am I doing? Let me run the code snippet and then you will get a better idea. So just let me run. When I ran, you got to see that the code snippet produced output in this format. By default, information and debugging messages are suppressed and the output is sent to the standard error. Other output options include routing messages through email datagram, socket, or to an HTTP server. New filters can select different routing based on message priority, debug, info, warning, error, and critical. This logging system can be configured directly from Python or can be loaded from a user editable configuration file for customized logging without altering the application. So whenever we need to log any use case or as per our requirement, we have to log something. So we can usually do so using the package logging. And it is quite essential to use logging module in our standard code practicing to maintain the logging of the code snippets. So this was all about today. Thank you. Have a great day.